Lecture 4. The Enigma of Quantum Consciousness. Soft, ethereal music plays as the title, The Enigma of Quantum Consciousness, appears on screen in the silent chambers of your mind. What force animates your thoughts? What mysterious current transforms electrical signals and chemical reactions into the rich tapestry of subjective experience? The question of consciousness, that ineffable quality of awareness, has haunted philosophers and scientists alike for centuries. But perhaps the answer lies not in the visible world of classical physics, but in the bizarre, counterintuitive realm of quantum mechanics. The domain where certainty dissolves into probability clouds and particles exist in multiple places simultaneously. Welcome to our journey into the enigma of quantum consciousness. In our previous lectures, we've explored the fundamental nature of consciousness, that inner light that illuminates our existence, and we've delved into the strange world of quantum physics, where reality itself seems to bend to the whims of observation. Today, we stand at the intersection of these two great mysteries, asking, could the quantum realm hold the key to understanding consciousness? Is the mind itself a quantum phenomenon? We'll explore several provocative questions. How might quantum processes in the brain contribute to consciousness? Could the measurement problem in quantum mechanics reveal something profound about the nature of awareness? And might consciousness itself be the missing piece in our understanding of quantum reality? Let us begin with the quantum measurement problem, a paradox that has perplexed physicists since the dawn of quantum theory. According to quantum mechanics, particles exist in superpositions, multiple states simultaneously, until they are observed or measured, at which point the wave function collapses into a single definite state. But what constitutes a measurement? What exactly causes this collapse? In the standard Copenhagen interpretation, measurement requires a classical measuring apparatus. Yet, ultimately, all observations are processed by conscious minds. This leads us to a profound question that haunts the borderlands between physics and philosophy. Could consciousness itself be the mechanism that collapses quantum wave functions? Is the observer effect a window into the fundamental role of mind in the fabric of reality? The von Neumann-Wigner interpretation takes this idea to its logical conclusion, suggesting that it is consciousness itself that causes wave function collapse. This would mean that consciousness isn't merely an emergent property of physical processes, it would be intrinsic to the fundamental equations of quantum mechanics. This interpretation places consciousness in a privileged position in our understanding of physical reality. If true, it would mean that mind and matter are inextricably linked at the most fundamental level of reality. Consider the implications. If consciousness collapses wave functions, does this mean that the physical world requires consciousness to fully exist? Does the universe exist in a superposition of all possible states until a conscious observer renders it definite? These questions blur the boundaries between physics and metaphysics, challenging our deepest assumptions about the nature of reality. But how might quantum processes manifest in the brain itself? The most developed quantum model of consciousness is the orchestrated objective reduction theory, or ORCH, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff. This theory suggests that quantum computations occur in protein structures called microtubules within the brain's neurons. These microtubules, they claim, can sustain quantum coherence, the maintenance of quantum superpositions, for time periods relevant to neural processing. According to ORCH, consciousness emerges from the orchestrated collapse of these quantum states, creating moments of awareness that string together to form our continuous conscious experience. This collapse isn't random, but follows a process Penrose calls objective reduction, a quantum gravitational mechanism that connects consciousness to the fundamental structure of spacetime itself. This theory is elegant and captivating, but it faces substantial challenges. The brain is warm, wet, and buzzing with activity, an environment seemingly hostile to delicate quantum effects that typically require extreme isolation and near-zero temperatures to persist. Critics argue that quantum coherence would decohere, or break down, far too quickly in the brain's environment to play any meaningful role in neural processing. They suggest that classical physics adequately explains neural activity without invoking quantum mechanics. Yet, proponents counter that certain biological systems, like photosynthesis and bird navigation, have been shown to utilize quantum effects even in warm environments. They suggest specialized mechanisms might protect quantum coherence in neural structures. The debate continues, with experimental evidence still insufficient to definitively support or refute quantum brain models. We stand before a magnificent uncertainty, a scientific mystery as profound as consciousness itself. Another intriguing quantum phenomenon that might illuminate consciousness is non-locality, the ability of entangled particles to instantaneously influence each other regardless of the distance separating them. Einstein famously called this spooky action at a distance. Could non-locality help explain the binding problem in consciousness, how our brains integrate diverse sensory inputs into a unified conscious experience? How does the visual processing in one part of your brain seamlessly combine with auditory processing in another to create your unified perception of this lecture? Some theorists propose that quantum entanglement might create a kind of neural symphony, binding disparate brain processes into the harmonious whole of conscious experience. In this view, consciousness emerges not from local neural activity alone, but from quantum correlations spanning the brain, a kind of entangled neural network. These ideas have inspired unified field theories of consciousness, which propose that consciousness itself may be a field-like phenomenon with quantum properties. Similar to how electromagnetic fields permeate space, a consciousness field might permeate reality, with our individual minds acting as localized excitations of this field. Testing such theories presents formidable challenges. How does one measure quantum effects in living brains without disrupting the very processes under investigation? Current technology cannot directly observe quantum coherence in neural structures, though advances in quantum biology are gradually providing new experimental approaches. One proposed test involves measuring the effects of anesthetics on potential quantum processes in microtubules. Since anesthetics suppress consciousness, if they specifically disrupt quantum coherence in neural structures, this would support quantum theories of consciousness. The experimental road ahead is arduous but essential, for without empirical validation, quantum consciousness theories remain in the twilight zone between science and speculation. The philosophical implications of quantum consciousness theories are profound, potentially transforming our understanding of mind-body dualism and physicalism. If consciousness operates through quantum mechanisms, it may occupy a unique category, neither purely physical in the classical sense nor entirely non-physical. This challenges the traditional dichotomy between dualism and materialism. If consciousness collapses wave functions or emerges from quantum processes that bridge the gap between possibility and actuality, it might represent a third category, a quantum-mediated phenomenon that transcends conventional physical or metaphysical categories. Revisiting the hard problem of consciousness, why physical processes give rise to subjective experience. Quantum theories suggest that consciousness may be built into the fundamental equations of reality. Perhaps subjective experience isn't an emergent property, but an intrinsic aspect of quantum systems achieving sufficient complexity. Quantum indeterminism, the inherent unpredictability of quantum events, also raises fascinating questions about free will. In a classical, deterministic universe, some argue that free will is merely an illusion, our choices predetermined by prior causes. But quantum indeterminism introduces genuine unpredictability into physical processes. If quantum events influence neural activity, and if consciousness interacts with these quantum processes, might this create a space for genuine choice? Could the mind influence quantum probabilities in the brain, creating a causal role for consciousness that transcends pure physical determinism? These questions reach beyond science into ethics and metaphysics. If consciousness possesses quantum properties that give it causal power in the physical world, our understanding of moral responsibility, human dignity, and the nature of personhood may require profound revision. As we stand at the threshold of this quantum consciousness frontier, let us summarize what we've explored. We've seen how the measurement problem in quantum mechanics raises the possibility that consciousness plays a fundamental role in collapsing wave functions. We've examined the orchestrated objective reduction theory, which proposes quantum computations in neural microtubules as the basis of consciousness. We've considered how quantum non-locality might address the binding problem in consciousness. And we've reflected on the philosophical implications of these theories for our understanding of mind, matter, and free will. Current research continues on multiple fronts. Quantum biologists search for evidence of quantum effects in warm biological systems. Neuroscientists develop ever more sophisticated tools to probe the quantum realm of neural activity. And philosophers refine conceptual frameworks to accommodate potential quantum aspects of consciousness. Yet the enigma remains. We stand before twin mysteries: the quantum foundations of reality and the conscious awareness through which we perceive it. Whether these mysteries are separate or aspects of a deeper unity remains an open question, perhaps the most profound question humans can ask. As we conclude, I invite you to dwell in the fertile uncertainty of this boundary between mind and quantum reality. For it is in this liminal space, this threshold between what we know and what we can only glimpse, that the greatest discoveries await. The relationship between consciousness and quantum mechanics remains elusive, a shimmering mirage at the edge of comprehension. But in pursuing this question, we may not only transform our understanding of consciousness, but also reveal new dimensions of quantum reality itself. Thank you for joining me on this journey into the quantum depths of mind. Until next time, may you marvel at the mystery of your own awareness, that inexplicable inner light that might, in ways we're only beginning to understand, be entwined with the very quantum fabric of the cosmos. Ethereal music rises again as the screen fades to black.